Hi, welcome everybody. Um, I'm Denise Savageau. I am the chair of the Water Planning Council's Outreach and Education Committee, and we're really pleased to have everybody here today for our extreme weather and watershed series. Today, we're going to be finishing up this series. We've had a series of workshops in the spring and had one in September, and today we're going to be talking about water quality and the impacts of drought. And we are in a drought, and there's things to be definitely to be talking about today. So I'm going to invite up as our first guest, Martin Heft. Martin is the chair of the Water Planning Council, and he's also oversees our interagency drought work group. So I will turn it over to Martin.
Thank you very much, Denise, and welcome. And on behalf of the Water Planning Council, thank the Outreach and Education Committee for putting this on and through this whole series. If you've missed any of them, I'm sure Denise will mention it later that they're all available, online. But Denise asked me to just want to touch base quickly. Earlier this month, about 10 days ago, the governor did declare a stage 2 drought advisory for the counties of Fairfield, Middlesex, and New Haven. Now, a stage 2 basically means that we're below normal precipitation levels in these regions, along with a number of other factors. There's no, advisories out that go out, to the public and everything. At this level, there's no water restrictions per se, but we do ask and try to make sure that we're out there encouraging people to voluntarily take steps to minimize, us moving up to a stage 3 in those regions or more in the others. These are things like shutting down your outdoor irrigation systems, minimizing overall water usage, looking at those, that leaky dripping, sink that you might have or toilet that keeps running, and any other, things from your local water suppliers. We know some municipalities have put some restrictions in to follow those, or from your water suppliers and municipalities. I will put a link in the chat to our drought page, which has all the background information on it. But did just want to say, we are in a stage 2 for those 3 counties. We do continue monitoring, on a daily basis, looking at everything from fire danger to, precipitation to groundwater levels. We look at, the public water supply systems. We also look, well, not a trigger, we look at private wells. And we have our sister agencies all reporting to us. So we do get all of that information in, as well as partners on the, federal National Weather Service, as well that, participate with that. So Denise, with that, I'll turn it back to you and thank you.
Thanks, Martin, for the update. We have 2 great speakers who are going to talk to us today. And I think, we know drought, and Martin, we talk about drought, we usually talk about the volume of water, the quantity of water. But we're going to be focusing on the impacts of drought from a water quality perspective, not a quantity perspective. So really think that this is an important topic because it's something we don't usually think about. Our seminar in September was about the impacts of flooding and water quality, and that's pretty obvious, but it's not always as obvious what the impacts of drought are on water quality. So we have 2 speakers today who are going to talk about that. Our first speaker is Paige Viciola Silva. She's the water quality manager with the Farmington River Watershed Association. And as the water quality manager, Paige's work involves conducting water quality monitoring and research projects. She manages the chloride monitoring program and various in situ continuous data loggers for temperature, conductivity, water level, and dissolved oxygen. She is responsible for managing data, conducting data analysis, and ensuring that quality assurance and quality control align with data quality objectives. Additionally, Paige writes research reports on the annual water quality report for the Farmington River. And then following Paige, we're going to get right into the next piece. It will be Evan Moore. He's an environmental analyst with the Regional Water Authority, where he leads programs that protect source waters, safeguards raw water quality, and ensures environmental compliance prior to this role, Evan conducted watershed inspections throughout the Regional Water Authority's public water supply watersheds and aquifers. And previously, he worked in lake and pond management for the better part of the decade, focusing on invasive species control and habitat restoration. His work reflects a strong commitment to protecting Connecticut's drinking water and the ecosystems that support it. So we're really pleased to have Paige and Evan here with us today, and I'm going to turn it over to Paige. Welcome, Paige.
Thank you for the nice intro, Denise. Hi, everyone. Just give me a second to pull up my presentation. So I'm from the Farmington River Watershed Association, and I'm going to be going over water quality trends we've seen associated with drought in the Farmington River Watershed. Just quickly, a little bit about our organization and the watershed. We are a nonprofit serving the Farmington River Watershed, and we do research, monitoring, stewardship, education, and advocacy. Some facts about the watershed. The Farmington River is the longest tributary to the Connecticut River. It does have 2 federal partnership wild and scenic designations. The watershed is 609 square miles, and it is in both Massachusetts and Connecticut, but primarily in Connecticut. And we do have drinking reservoirs, especially one that supplies drinking water to the greater Hartford region. We have been collecting data since 2004, not for every parameter, but for most. So we have a lot of long-term data that we can look at. And especially for this presentation, reveal trends associated with our changing climate and extreme precipitation events through this long-term monitoring. Little bit about drought. Like Martin said, there are different stages to drought. It can vary between abnormally dry and exceptional. And with that, we see less precipitation events, and then we have lower water levels and flows. And what we see is increases in temperatures for water, and then also increases in contaminants in the water. We may see contaminants in the groundwater present themselves during drought as that groundwater is feeding the streams. We also see cyanobacteria blooms, and with that, we also have decreased habitat and connectivity, especially through road stream crossings. And I just want to note that all streams and rivers, and even their own segments, they all have their own land uses, which can worsen water quality or help protect them with water quality. And like it was mentioned, this is not the most up-to-date map on drought in Connecticut. They just put out a new one, but we are currently in drought, and I believe the moderate has maybe decreased a little bit, just the area. So I'm going to go into some programs that we do. This is river and streams and not reservoirs and lakes yet, but I'll get to that later to talk about what trends we've seen with these programs in relation to drought. So we do monitor bacteria. That is for recreation. We look at total coliform and E. coli because E. coli can make people sick. We do not monitor any designated swimming areas. The state does that. So you may have seen beaches closed due to high bacteria. We do it. Our data is used for assessments by the state, and then we could also look at long-term trends. So we see lower water level and flows, especially with urban areas that have impervious surfaces and agricultural lands. They worsen water quality, and then precipitation events, whether they're small or large, we get stormwater runoff off the land that carry those contaminants into the water bodies. So especially during drought, when lands are pretty dry, we get some good runoff, even just from a small storm. And then we see spikes in bacteria. We have seen locations that tend to be impaired. They worsen in drought, but thankfully some locations that are protected, so they're forested and they have good buffers, they tend to remain clean. And then of course we have locations that can flip-flop depending on what type of weather patterns we get over the summer. So they may worsen or they may actually improve. We also monitor temperature, and this is primarily looking at summer temperature averages for sensitive species such as trout or slimy sculpin. So when we have lower water levels and flow from drought, we of course see increases in temperatures. We could also see decrease in habitat. As you can see in this picture, this is a stream, although it's mostly boulder at this point during a drought. So we lose some connectivity. We get warmer temperatures, especially through road stream crossings when we're in drought. It can decrease aquatic passability. So we've seen, again, those protected areas, they actually tend to do okay. But of course, there are locations that warm up during drought that tend to be cold. And then something interesting, it's a little different. The Farmington River does have a flood control dam in Colebrook, and that is right on the border of Massachusetts. And they release water from the bottom of the reservoir, and that water is nice and cold. And actually, in a drought year, the river is colder than normal because of those releases from the dam. For chloride, we look at chloride in relation to road salt applications and how chloride can affect aquatic life. So road salt applications in winter months related to winter storms and icing events. If you didn't know, we actually had a winter drought last winter. It started in the fall and it did carry through the winter. So we saw higher chloride levels than we normally would because we were still getting snow and icing events. So they were applying road salts, but we also were in a drought. So those concentrations were a lot higher than we normally would see. Now, you normally don't really think of road salts and chloride in the summer, but they do linger in the environment. They can contaminate groundwater. So when we're in drought in the middle of summer, we actually see higher chloride because that groundwater is feeding that stream. The Farmington River itself and reservoirs tend to fare well, primarily due to the size of the water body. And then the big one, cyanobacteria blooms. If you don't know, cyanobacteria is naturally occurring. It's a photosynthesizing single-celled microscopic organism. And what happens, especially in drought, is when we have lower water levels and flow, we get warmer waters, especially in impoundments, combined with available food for cyanobacteria, so nutrients, we can get cyanobacteria blooms. The problematic part of that is that they can release cyanotoxins, which is where we get harmful algal plumes. So this is not drinking water, thankfully. This is Rainbow Reservoir. This is where we've been getting cyanobacteria blooms. This is an impoundment on the Farmington River in Windsor, which is about 8 miles to the confluence with the Connecticut River. And because it's only 8 miles to the confluence, it's getting a lot of the watershed input from upstream. I have pictures from a bloom that happened actually this last summer. And you can see that cyanobacteria can be very bright green, could have streaking, could also have shore accumulation that looks like pollen or even a duckweed. And we have been monitoring Rainbow Reservoir since 2021. So we go out on the boat in the middle of summer and we get samples for cell counts and cell identification. We also get samples for nutrients. We may take samples that can be analyzed for cyanotoxins. And we also use a multi-parameter meter that can measure temperature and dissolved oxygen, chlorophyll and phycocyanin, turbidity and conductivity. And with this, we can get some ideas of what's happening in the reservoir. So this is 2024. There was no bloom. And this is just a good example of, what we would look for is that we have pretty uniform throughout the column. And then this is this summer during a cyanobacteria bloom. And we could see the effects of that where dissolved oxygen is very low, especially in the top meter, and temperatures are very high. Like I said, we do sample for nutrients too. We do that at all our locations on the reservoir, but also looking at inputs of these nutrients into the watershed. So how much is actually coming into the watershed, into the reservoir. And then a fun graph, this is just tracking the cyanobacteria bloom over the summer, which you don't get to see a whole lot. Phycocyanin is exclusive to cyanobacteria, so we can see when it's higher than chlorophyll or in an active bloom, and then we can see its resolution at the end of August. Now, there are other types of aquatic invasives. It's not just cyanobacteria. There may be other types of algal blooms. They don't have cyanotoxins. But what happens, especially, thinking of hydrilla, but there's also water chestnut and other types of aquatic invasives, is that when they take over the water body, they can slow the water down and it can warm up and it can essentially become a host location for cyanobacteria. I like to say, when in doubt, stay out. And if you see something, say something. You can report it to Connecticut Deep, Department of Public Health. The EPA also has a Bloom Watch app where you could take a picture and submit it. So when in doubt, stay out and always report it. If you're interested in any of this in more detail or any of our other work, we do put out water quality reports. We also put out special research reports, so you can visit them on our website.
Thanks, Paige. And we're going to hold questions till the end. So why don't we invite Evan up? And you can share your slides, Evan.
Thanks, Denise. And thank you, Paige, for that wonderful presentation. Let me just get this up here. Can you see my screen?
Looks good.
Yes.
Okay, thank you. Let's get going here. All right. Good afternoon, everyone. My name is Evan Moore. I'm an environmental analyst 2 for the South Central Connecticut Regional Water Authority, where we manage both surface and groundwater sources that supply drinking water to our communities. Today, I'd like to give you an overview of how droughts, these long dry periods we've all seen more of lately, can affect not just how much water we have, but how clean that water is when it reaches our treatment plants. We'll look at surface water, groundwater, and watershed management, including issues like cyanobacteria blooms and drought-stressed forests. Before we get going to the next slide, I'd like to tell you all a little bit about the RWA, give you a little background. So we average about 45 million gallons a day distributed to our customers, which are about 430,000 customers in 15 towns here in New Haven County in southern Connecticut. We have 10 active reservoirs, 4 surface water treatment plants. We own over 27,000 acres of land, and there's about 140 square miles of public water supply watersheds and aquifers that contribute to our system. And on this slide, the image in the background there is our Lake Hammonasset Reservoir straddling the town boundary of Madison and Killingworth. This is a particularly low period that this picture was taken in. I don't believe it was taken this year, but in previous years. Typically, all this green is filled up with water. So this is very low conditions, abnormally dry conditions. All right. So let's start out by defining a drought. When we think of a drought, we usually picture dry lawns or empty reservoirs, but there are actually several different kinds of droughts. A meteorological drought is simply less rainfall than normal. Hydrological droughts are when there's a lack of rain that leads to reduced stream flow, reservoir levels, or groundwater recharge. And agricultural droughts impact crops, soil moisture, and forests. For us as the water utility, all 3 of these matter. Less precipitation means less water entering our reservoirs and aquifers, and those reduced inflows can last long after the rain finally returns. Droughts in Connecticut are becoming more frequent and more intense, despite overall precipitation increases due to climate change. This is causing precipitation to arrive in more extreme, heavy events rather than steady, moderate rainfall. And the graphics on this slide are the most recent drought monitor map that was released yesterday morning. You can see that Southern Connecticut is impacted more than the rest of the state. However, the majority of the state is in an abnormally dry state right now. New Haven County is where we're based in, so a lot of our system is affected by this moderate drought right now. A lot of our water system and water supplies lie within that moderate drought area. It's a little bit better than it was last week due to the rain we finally received after waiting quite a while for some, but there's still a long way to go here to get us out of this abnormally dry period. All right, how do droughts affect water supplies? As drought continues, two things happen. Supply drops and oftentimes demand rises. Streams shrink, reservoirs don't refill, and groundwater levels decline because recharge is minimal. Meanwhile, people continue to water their lawns, fill pools, and use more water to compensate for the heat. From a utility standpoint, this means we're managing our water portfolio much more carefully, sometimes shifting between surface and groundwater sources, issuing conservation advisories, or tightening pumping schedules to avoid stressing aquifers. It's a balancing act between maintaining supply and protecting long-term sustainability. The image is here on the right. The top image is a pond adjacent to one of our drinking water reservoirs in a very low period. I believe this was taken within the last couple of years. You can see that building on the left where the water line usually sits, and it's quite low compared to that. The picture on the bottom is our Lake Gallard Reservoir in North Branford. You can see that due to some really dry conditions in the lower lake level, that there's a increased erosion to the dry lake bed there, which is another issue. Water quality impacts to the surface waters. Quantity is one issue, but quality changes as well. In reservoirs and streams, drought reduces the inflow. So pollutants like nutrients, metals, and organics become more concentrated. I'm sure many of you have heard the old adage, dilution is the solution to pollution. So warmer water holds less oxygen, which can lead to algae growth, fish stress. Less mixing and circulation mean the water can stratify, warm water on the top, cool water on the bottom, which makes treatment more difficult once we draw that water in. Utilities might notice higher levels of color, taste, or odor compounds, or an increase in natural organic matter that reacts with disinfectants to form unwanted byproducts. This is the image on the right is our Lake Chamberlain Reservoir in Bethany on a beautiful summer day. So let's talk about the water quality impacts to groundwater. Groundwater isn't immune to drought either, but oftentimes does not garner as much attention as surface water supplies due to groundwater being much less visible than surface water supplies. So when recharge slows, the water table drops, and as wells draw from deeper layers, the water chemistry can change. You might see higher concentration of minerals like iron, manganese, and increased hardness. In some areas, lower groundwater levels can allow salt water to creep inland, especially near the coastline. This isn't an issue for the Regional Water Authority. Our supplies are not impacted by the salt water from Long Island Sound. There's also the potential for contamination from surface sources, such as septic systems, if shallow wells lose pressure and draw from unexpected flow paths. Utilities have to increase sampling, adjust treatment, and monitor trends closely during extended dry periods. The image on this slide is a good representation of the relationship between surface water and groundwater supplies. I know Paige gave a much more detailed explanation of cyanobacteria, but I figured I'd throw in a slide and have it relate to drinking water a little more explicitly. So one of the most visible drought-related issues in lakes and reservoirs is cyanobacteria, also referred to as blue-green algae. So these organisms thrive in warm, still, nutrient-rich water, which are conditions that droughts tend to create, making it ideal for these cyanobacteria blooms. Some species produce toxins that can cause health concerns for people and pets if they enter drinking water supplies. I'm sure many of you have seen in recent years a lot of news stories about pets becoming sick and passing away, unfortunately, from exposure to these cyanobacteria blooms. When a bloom occurs, utilities take several steps: increase monitoring and testing for algal toxins, adjust intake depths to avoid the bloom layer, use algicides or powdered activated carbon, and in some cases, employ advanced treatment like ozone or membrane filtration. Public communication is also key. We always want residents to understand that utilities are watching these conditions closely and taking appropriate steps to ensure distribution of high quality drinking water. This image on this slide is from our Lake Monunketuck Reservoir in North Guilford. I'm not sure exactly when this cyanobacteria bloom occurred, but as you can see, it's pretty nasty. And there are some beautiful fall foliage in the background as well. Okay, so there are obviously some impacts on the treatment operations due to the impacts of water quality on the raw water. So inside the treatment plant, drought can make things a lot more complicated. Changing raw water quality means operators may need to tweak chemical doses daily or even hourly. We may use more coagulants, activated carbon, or disinfectants to keep the finished water safe and consistent. These adjustments can increase costs and residual volumes, and filters can clog more quickly due to algae or organics. Utilities plan for these variations, but prolonged droughts stretch staff, budgets, and infrastructure. So obviously, proactive maintenance and monitoring are crucial and more effective. This is an image of our Lake Saltonstall water treatment plant in East Haven. The Lake Saltonstall Reservoir is just north of this frame above the highway there to the top of the image. That's Furnace Pond to the right of the image. So let's talk a little bit about forest and watershed management challenges. Beyond the water itself, drought also affects the land that feeds our water sources. When forests are when forests are stressed by heat and dryness, they're more vulnerable to pests, disease, and wildfire. Wildfires, in turn, remove vegetation and expose soils, making it easier for sediment and nutrients to wash into reservoirs when rain finally does arrive. For utilities that own or manage watershed lands, this creates major challenges: maintaining healthy forests, preventing erosion, and coordinating with local land trusts or local, state, and federal agencies on drought resilient management and reforestation. At the RWA, we have a dedicated team of foresters and natural resource analysts who work tirelessly to make sure our lands are managed correctly. Source water protection becomes more complex under drought conditions. We have to think both short-term and long-term. This is an image of the woods surrounding our Lake Gillard Reservoir, and just some of our staff doing some maintenance on the roadways, some maintenance on the trees and the land. So strengthening source water protection. So what are utilities doing to prepare? First, we diversify. Having both surface and groundwater sources provides flexibility when one becomes stressed. Second, we invest drought resilient operations, conservation programs, and leak detection. Third, we strengthen watershed partnerships, working with municipalities, farmers, forest managers, businesses to reduce nutrient runoff, protect riparian buffers, secure key land parcels. All of these efforts tie into one goal: ensuring reliable, safe water supplies, even during prolonged dry spells. So to wrap up, drought impacts water in two big ways. It reduces quantity, and it also changes the quality of the raw water. Utilities must adapt through monitoring, treatment adjustments, and proactive watershed management. Cyanobacteria blooms, stress forests, and shifting groundwater conditions are all reminders that drought management isn't just about conserving water. It's about protecting the entire source-to-tap system. By working together as communities, through conserving water, supporting land protection, and staying informed, we can help make our water systems more resilient for the future. And with that, I would be happy to take any questions from anyone if that's what we're doing right now. Thank you.
Thanks, Evan. That is what we're going to be doing right now. So I don't,
Fantastic.
yeah, so I don't know if we have any questions in the chat yet, but let's see. So we do have one, so we'll just start with that. And it's, how is water quality impacted if there is a wildfire during a drought? And I think you talked about that a little bit, Evan, but maybe you can expand on it.
Yeah, so the wildfires essentially, that impacts the land. So there's less vegetation cover on the watershed lands, which would lead to less nutrient uptake from the vegetation. There's more exposed soils, which result in higher possibility of erosion. What else? Sediment and nutrients makes it easier for them to wash into the reservoirs. And they also are more susceptible to pest disease, and the trees that are impacted are more susceptible to pests and disease.
Yeah. And I think during the, when we have a wildfire, then, we have to think about fire suppression and what they're doing in terms of, bringing equipment onto the properties and managing that way, so that we don't have erosion during that. So we have a question also here for Paige, and it says, can you expand further on the chloride testing that the Farmington River watershed does? Roughly how much did chloride levels increase during a winter drought without precipitation to dilute it?
Yeah, that's a great question. So we do monitor chloride year round. We do have locations that are problematic, primarily where we have urban areas and impervious surfaces. So they tend to always have issues in the winter, but we've also seen issues with them in the summer. This last winter, we saw locations that may have higher chloride, but nothing too concerning. They were high. Our locations that are problematic were very high, and some locations that never have problems increase, not concerning, but increase. So we kind of saw that across the whole watershed, that chloride just in general was a lot higher this last winter than we normally would see. And if you're curious, we do use a multi-parameter meter for that, but the Isaac Walton League of America also provides salt watch kits, which are just dip strips if anyone's interested in doing their own sampling.
Thanks, Paige. Evan, I was wondering if you...
Denise, you muted yourself.
You muted, Denise, yeah.
Sorry about that. Evan, could you, I don't know how I clicked on that. I was focusing on something else, I guess. Anyway, Evan, could you expand a little bit more on source water protection and how the impacts of, or I should say the benefits of protecting our forests and the land within the watersheds, prior to drought or prior to flooding? So that, how they're making them more resilient.
Yeah. So for the forests.
Yeah.
So the forests, we do timber harvests. We do a lot of land management around our property. We've got crews out there making sure that there are healthy forests out there. That's about the extent that I really know about what they're doing. I'm more involved with the, not really the forest side of things, but I'm more involved with source protection within the community, and the more populated areas are more urban areas.
Okay.
So we're doing more proactive, ensuring that there are less potential contamination sources, and we're checking on non-point source pollution within local businesses, and ensuring that folks within the public water supply watershed are compliant with source protection best management practices.
All right, thanks. I'm just wondering if anybody, if you haven't put a question in the chat, if anybody would like to raise their hand. Mike, go ahead, Mike.
Thanks, Denise. Great job, Evan and Paige. Appreciate everything you talked about. My question is for Martin. I think we may have talked about this in the past, but the two different drought designations. So the U.S. Drought Monitor that both Paige and Evan showed us in abnormally dry and stage 1 versus the governor's proclamation last week that said that we're in stage 2 in Fairfield, New Haven, and Middlesex counties. I'm just wondering if you think that's confusing for people to see these two different designations, because they weren't the same. And I actually had someone reach out to me, a student here that was doing a story on this, and I didn't realize that they were different at the time until I looked at it. So I'm just wondering if you can comment on that, Martin.
Sure, more than happy to. I think the biggest thing, yes, it does get a little confusing because there are different, and I know it was mentioned during the presentation, there's different levels of drought, different ways different people monitor it. We do use the information that you mentioned as part of one of our triggers, if you will. We have 9 triggers that we look at through the interagency drought work group that all go together. And you can, through the link I put on there, you can actually look and see that data of those 9 triggers and where we are with all of those areas. So we don't only look at one aspect of drought. We look at 9 different areas plus. And I say plus because we have, the weather service, we look at weather, we look at private wells, we look at other items that are not necessarily in the plan to make that decision. So we're looking at a broader base of, the whole impact of drought rather than just one element of either precipitation. And most people think of that as the only item in drought because we're saying, oh, well, look, we just got rain, governor declares drought and the next day we get, 1.5 to 2 inches of rain. We must be out of drought. No, unfortunately, and this happened, previous years when we were in a stage 3, we'd get a heavy rainstorm. Problem is that heavy rainstorm was all runoff. So it doesn't change the groundwater. It doesn't change the fire danger. It didn't change all these other triggers that we look at. So yes, it's confusing when, the media is out there saying, oh, well, U.S. Drought has said we're in this stage, but Connecticut hasn't done that. You can go through, read some of the comments of, when press stuff goes out and they're like, well, duh, what do you mean we already knew we were in drought? Well, we were in drought of that, but under this plan, this is what drought means. So it is an education process. And I know our state drought coordinator was on, CPTV yesterday, just discussing it, type of thing. So it is always an education process there, but that's kind of the differential.
That's great. Thanks, Martin.
Thanks, Mike. Any other questions for any of our speakers? Okay, Jane Browerman asked a question. Let's see, what does it say here? What about protecting riparian areas and drinking water supply watersheds? Is there something the water company does, Evan?
Evan, you're go.
Yeah, thank you. Yes, we absolutely are interested in protecting riparian areas. That serves as a great line of defense for preventing, pollutants and contamination and bad quality stormwater runoff from entering our source waters, our surface waters, my apologies. So yes, that is something that we do. We certainly implement that on land that we own. And as far as land that we don't own, we do work with private landowners and property owners to, encourage them to implement proper riparian buffers to protect the source waters.
Yeah, thanks. I think it's important, Evan, maybe you could just expound on this a little bit, that so much of the watershed, of the public drinking water supply watershed is in private ownership, not controlled by the water utilities. And I think a lot of people don't know that. So that when we're looking at protecting forests, riparian areas, could you just expound on that? Because you were talking about, working with communities, and I know that may be the forestry piece of it, but could you just talk about that a little bit more in terms of your relationship with communities and a broader drinking water supply watershed?
Yes, absolutely. So we have sort of a couple different watersheds within our system, geographically. Our Lake Whitney watershed in Hamden, Connecticut is very urbanized. We own very little land around that reservoir and the Mill River system. So I think we own something like 5% of the land within that watershed. So that poses a unique challenge because, like Denise said, we don't really own that land. So there's very little control that we have over that land. We do reach out and work with local land trusts, local stakeholders to try to acquire property within the area adjacent to the reservoir, areas deemed high priority. Sometimes this is easier than others. And, especially in the real estate market that we're living in right now, where prices are incredibly high, a lot of these parcels that may go up for sale are a little unrealistic for us to purchase based on the price. So within like the Lake Whitney watershed, we implement a lot of like stormwater management systems on the small amounts of land that we do own. We are focused on, riparian buffers where we can implement them within the public water supply watershed of Lake Whitney, but there's only so much we can do. So we have to get a little creative with it. And stormwater treatment systems are kind of our solution to that at this point. We have about 7 or 8 around Lake Whitney that help to improve the stormwater quality going into the lake.
Thanks, Evan. And I have another question. How do you treat or prevent the algal blooms or other invasives? And I know, well, let's take it, Evan, for for the drinking water supply, and then Paige, if you have some comments on that as well.
Yeah, so we do. I know historically water utilities have used copper to treat algae and cyanobacteria. We don't prescribe to that solution. We have begun exploring using hydrogen peroxide as sort of a proactive measure to get ahead of the anticipated blooms in some of our more susceptible reservoirs earlier in the season to kind of mitigate the chance of these blooms occurring later in the season. That seems to be working out pretty well. I believe the product's called Green Clean Pro. It's a granular powder that they blast off into the reservoir, and it has pretty good results as far as mitigating the cyanobacteria blooms.
Yeah, and just quickly before we turn to Paige, could you talk about the benefits of the hydrogen peroxide in terms of the residual impacts, from a chemistry perspective?
Yeah, I'm not a chemist and I don't pretend to be, but from my understanding, it's a pretty inert substance. Once it gets into the water and kind of does its job, it's a little less, what's the word I'm looking for? A little less, I don't know. It's a little better than using copper. The side effects of it are a little bit better than using the copper sulfide.
All right, thanks.
Yeah.
Paige, I'll let you jump in there.
Yeah, I was going to say the same thing. I know it as pelletized peroxide. It is good to use before a bloom starts, and it is very short-lived but effective and doesn't typically harm a lot of the species. But at least, in our case, you do need state permits and stuff to do that, and NDDBs for the aquatic life in that water body. In terms of other invasives, I'd mentioned hydrilla and water chestnut. If you don't know, hydrilla can be very hard to get rid of, and I do know the Connecticut River has a particularly aggressive strain, especially when you pull it, it tends to fragment and then it can reestablish. Similarly with water chestnut, their seeds last a very long time, and each one drops so many seeds a season. So once it's established, it's really hard to get rid of. But again, there are treatment options for that. I know for FRWA, for water chestnuts, we do hand pools of volunteers and things like that. So it does depend on the species.
Thanks, Paige. And let's see, do we have any other questions? And then it says, so I have a question. It says, metals tend to increase in groundwater. By how much the metal concentration increase in groundwater, in waters? I think, Paige, did you talk about metal concentrations or?
No,
No,
just fluoride.
Oh, maybe Evan did.
touched upon it briefly. I don't have, I would be guessing if I gave you an answer on that. I might be able to dig into that and get back to that person if they'd want to contact me separately.
Okay. Are there any other questions? Okay, without any other questions, I want to thank our presenters for joining us today on this water as we end up our extreme weather and our watersheds. We know that this is something that's really impacting us and continuing to impact us now in terms of the drought, but the idea of water quality and these extreme events is really important. And thank you, Martin, for giving us the update on the drought where we are now. I really appreciate it. So thank you, everybody, and look forward to this is our last workshop with the Water Planning Council program that we have this year. We'll be starting up again usually in February or March. We'll be starting our new series, and we'll be looking at that and getting information out. We have in the chat our website where you can go and look at all of the prior webinars we have. So hopefully people will take advantage of that. And I think soon we're going to have everything out on YouTube. We have a new YouTube channel with the Water Planning Council, and we'll have all of these on YouTube, so you'll be able to search through them. So we're looking forward to that as well. So thanks everybody for supporting our program, and we'll see you in the spring. Thank you.